and welcome back to Teacher Gimbal channel. Today we're going to be going over Illustrative Math, Algebra 1, Unit 1, Lesson 13 Practice. If you like this video, make sure to give it a like and subscribe to the channel so I can keep creating more. Let's get started. Problem 1. 3 drivers competed in the same 15 drag races. The mean and standard deviation for the race times of each of the drivers are given. Driver A has a mean race time of 4.01 seconds and a standard deviation of 0.05 seconds. Driver B has a mean race time of 3.96 seconds and a standard deviation of 0.12 seconds. Driver C has a mean race time of 3.99 seconds and a standard deviation of 0.019 seconds. Which driver had the fastest typical race time? So on average, the fastest race means that they finished the race in the shortest amount of time. So in this case, the driver that had the fastest race time is driver B, because 3.96 is the shortest race time out of those 3 race times. Which driver's race times were the most variable? When we're looking at variability, we want to look at the standard deviation, because the standard deviation tells you how variable your data is. The most variable implies the highest standard deviation. And in this case, driver C, with a standard deviation of 0.19 seconds, has the highest variability. Finally, which driver do you predict will win the next drag race? Support your prediction using the mean and standard deviation. So let's look at this. Driver A had a mean of 4.01 seconds and a standard deviation of 0.05 seconds, which means he, in general, ran a race or drove a race somewhere between 4.01 minus 0.05 seconds or 4.01 plus 0.05 seconds. So in general, his race was somewhere in between 3.96 seconds or 4.06 seconds. Driver B had a mean race time between 3.96 seconds and a standard deviation of 12, so somewhere in between 3.96 minus 0.212 or 3.96 plus 0.12. So his race times in general were somewhere between 3.84 and 4.08. Finally, driver C had a mean race time of 3.99 seconds and a standard deviation of 0.19 seconds. So his race times were somewhere in between 0.08 and 4.18. So he had the potential of going the fastest, but also had the potential of going slower. I think in this case, the best bet would be to choose driver B, because his standard deviation tends to put himself into a range that's not quite as low as driver C, but more consistently probably lower than driver C. However, you could actually answer this question in more than one way. So depending on what you think, the variability, the effects on the means, you'd be able to answer this as long as you support your prediction. All right, so we're using the standard deviation to determine kind of the range of times each driver has in their races and which one's most likely to be the fastest on another race. If you need a second to pause this video or to think about what I did, make sure to do it now before I go on to problem number 2. The widths in millimeters of fabric produced at a ribbon factory are collected. The mean approximately, so we got our ribbon. Sometimes I like drawing pictures because when it says the width of ribbon, I have to think about what that means. So the mean is approximately 23 millimeters and the standard deviation is approximately 0.06 millimeters. Interpret the mean and the standard deviation in context of the problem. So in this case, we have a bunch of different ribbons that are being created. In general, the width of each ribbon on average is 23 millimeters long. So the width would be 23 millimeters long. The standard deviation means that the variation from the mean is about 0.06 millimeters. So some are a little bit bigger than 23 and some are a little bit smaller than 23, but in general, it's about 0.06, greater than 23 or less than 23 variation from the mean. Select all the statements that are true about the standard deviation. So, our standard deviation, is it a measure of center? No. The standard deviation is not a measure of center. That would be the mean, the median, or the mode. B, Is it a measure of variability? Yes, it tells us how much our measure of center varies. It is the same as MAD. It is not the same as MAD. The standard deviation is calculated different than we calculate the mean average distance, even though the mean average distance is also a measure of variability. D, it is calculated using the mean. Yes, you do use the mean to calculate it, just the same way you use the mean to calculate the MAD. E, it is calculated using the median. No, you do not use the median to calculate the standard deviation. We use the mean. It is the distance from the mean, not the median. All right, problem number 4. The number of different species of plants in some gardens is recorded. So we have all these different species of a plant in the garden. What is the mean? So in this case, we are going to copy our mean data, Control C, move it into our one quantitative variable single group, and begin our analysis. Now this website that I'm using is stablet.com. You can see in other videos how I get to it and why I like it. So in this case, our mean is 4.5. So we're going to write that down. Mean equals 4.5. And our standard deviation, which I get right here, is 2.173. That's it. That was pretty easy. I like that question. Question number 5. A set of data has 10 numbers. The mean of the data is 12, and the standard of the deviation is 0. What values could make up the data set with these statistics? Well, if the standard deviation is 0, it literally means that none of the values deviate from the mean. So if the mean is 12, that means all the rest of the numbers are 12 as well, because there is no deviation from the mean. The mean, every single value is exactly the same as the mean. It doesn't deviate, it doesn't change, it's not greater, it's not smaller. So all 10 values of this data have to be the number 12. If you remember from lesson 11, we just went over a question, or lesson 12, I think it was, where all the data set was the number 7, and we calculated the mean and the standard deviation as the number 7 and 0. Problem number 6. Which box plot has the largest interquartile range? So the interquartile weight range we can calculate by looking at these boxes over here. Immediately, I see this one has the biggest interquartile range, but let us go ahead and do some calculations. Between 12, this has to be 24, 28, so the middle number here has to be 26, so that would be 27, this would be 12. The difference would be 15. So this value here is Q3, and here is Q1. So the IQR, if you remember, the way to calculate it is the difference between Q3 and Q1. So I calculated it here as 15. Here, this would be 13, and 24, this would be 25. The difference between 13 and 25 is 12. So this one is still the greatest IQR. This looks like it's at 25. This is at 32. The difference here, the IQR would be 7. Up here, this is 5, and this is 12. The distance here is 7. So as you can see, we just calculated the IQR of every box plot, but this one is the greatest IQR. We also did that visually, so it's very easy to see visually that our IQR is the greatest IQR is D just by looking at the width of the box. And that is a valid method for calculating the largest or the smallest IQR while looking at a few different dot plots. All right, question number 7. What is the 5-number summary for this data set? And if the maximum is 17, what is the 5-number summary? So let's go ahead. We're going to go back and use our data analyzer because in the first 10 lessons, we went over this a lot, and now we're ready just to analyze it here. That's not going to stop me from using my table just to identify my 5-number summary. So I like my min, my max, my median, and then here's my Q1 and my Q3. So my min of this data is 1. My max is 17, and it has that in our table over here too. Our median, which is the middle number, is 6. And in this case, we have our Q1, which is 3, and our Q3, which is 10. All right, that was it. Now it asks us when the maximum 17 is removed from the data set, what is the 5-number summary? So we're going to remove the 17 from our data set. We're going to re-begin our analysis and click over here and create our new table. So our second 5-number summary that we have, we're going to draw another table. We're going to have our min, which is 1 still. Our max has now changed to 10 because we got rid of the 17. Our median is 4, so it has shifted down from 6 to 4. Our Q1 is still 3, and our Q3 is 9.5. And that is our new 5-number summary. So I know we're given a lot of values over here. These are the numbers that we care about for the 5-number summary. So if you have any questions, as always, leave them in the comments below. Hope you like this video, and if you did, please like and subscribe to my channel to receive more like it. See you next time.